Good morning, good afternoon, and good evening to everyone who's joined us today. Thank you for joining us yet again for another episode here at amazic.com, where we're crazy about Kubernetes. We love all things cloud native, and we want to bring you the best, the hottest, the latest, and the greatest from this space. And that's what we do. Every week, we speak to different influencers and leaders who are working on really cool and unique stuff that you need to know about. So if you like what you hear here, I want to encourage you to check out all the other stuff that we do at amazic.com. That's amazic.com. I'm Twain Taylor, editor at Amazic. And I have with me today Benjamin Wilms, who is the CEO and co-founder of this cool company called Steadybit, which is based out of Germany, I guess. Ben, you can confirm that. But it's just great to have you on the show, Ben. Thanks for joining us.
Thanks a lot for having me. It's a pleasure to be here. And I'm curious about our conversation.
All right. So, the topic for today is chaos engineering. So I'm guessing some of you would have heard of this phrase, chaos engineering. And for some of you, it may be new. But it's definitely not a very, widely practiced thing in the space. It's something that's, something that's gaining traction is what I think of it. And Ben can obviously shed more light on this. So we're going to talk about that. So it's going to be a really cool conversation, something that I think everyone is going to have something to take away from this. As we start, Ben, I want to just get to know you a bit more. If you could tell us a bit about your background and what you've been up to up until Steadybit, that would be a great start for us.
Mm-hmm. With pleasure. So I'm Benjamin. I'm one of the founder of Steadybit, and I'm a developer by heart. I started my career in 1999 as a software engineer, as a software developer. And since day one, you can call me the paranoid guy, because I need to test in detail. I need to test under specific conditions. It's not that I'm happy after just a unit test or something like, I call it the happy path testing. So I would like to test the software in a more detailed way. And that's what I'm doing since a long time, as I started in 1999. Later in my career, I joined a consultant company. The name is Concentric, and there was like there is still be a very special type of culture. So you are allowed to spend 1 day a week for open source activities, to do public speaking on conferences, to write articles, blog posts, do podcasting, whatever. Something where you as a human can improve yourself, can do something for you to level up your skills, but also to share what you have achieved with the community. And that was my starting point, where I started with chaos engineering. It is about 7 years ago, because I was working in a project at my former employer, and I joined very late in the project, and I was able to take a look at the code base. I was able to take a look at the load tests. Everything was looking pretty good, but then it was like, okay, now we need to go in production. And now this paranoid guy is coming back, and we should test under hard conditions. Let me inject bad behavior during the execution of load tests. And that was like, where I started with chaos engineering, with the principles of chaos engineering about 7 years ago.
All right. Wow, that's a long way. I mean, that was like really early days for chaos engineering. And how did you and your co-founder meet when you started Steadybit?
We all worked at our former employer. So we all worked at the same company. And so we have done some projects together as colleagues, and that's how we get to know each other.
Awesome. And how long ago was that you started Steadybit?
Steadybit was founded in 2019. So what is today? 24.
23
years ago.
4 years is a long time in startup world. So you've been around.
It's like a roller coaster. You are riding a freaking roller coaster.
Absolutely. So, you've been working with this for 7 years or more,
Mhm.
chaos engineering. So, you'd be a great person to really give us, a brief explanation of what it actually is. So, how would you define chaos engineering to someone who doesn't know what it is?
Mhm. So yeah, with the principles, with the methods behind chaos engineering, you are able to inject bad behavior, to simulate turbulent conditions, and to verify if your system is able to handle this kind of situations or not. So for example, maybe you have implemented some fallback strategies in your system where under specific conditions, something should be triggered, like a fallback. That's something you should test before this will be called in production the first time. So you need to test in a proactive way if your system can handle specific outages or not. And in the original terms, or like in the beginning of chaos engineering, it was like you should do it in production only, because production is the single point of truth. It's where your system is working, where all your users are working, but that's changed tightly, or a little bit. That's something we can maybe talk later on.
Yeah. So the first time I heard of the term chaos engineering was, when I read about Netflix and what they were doing related to this. So they created this bunch of open source tools, and they called it the Simian army. And yeah, it was really an interesting read, a bunch of their tech engineering blog posts talking about how they
Yes.
destroy their own live instances and force teams to figure out how to make sure that the system doesn't go down. That was the first time I heard of it. And probably for a lot of people, that was probably the first time they heard of that term as well. Could you tell us a bit about just, those times, what Netflix was doing and what was significant about that project? Just memories that you have around that.
So Netflix was getting chaos and engineering into their organization. They have rolled it out into the organization. They have enforced their developers, engineering teams, product teams to be able to handle specific conditions. But it was still in this early days something very randomly injected. So
Okay.
the team was like creating a new feature. They need to release it in production. And on the other side, there was like the group who has created the Simian army, and the Simian army was like injecting a region outage and zone outage, latency with the latency monkey, or like with the original chaos monkey who killed randomly EC2 instances. So now the team was able to know, okay, if I'm in production, okay, I will be hit by a monkey. I will be challenged by a monkey, and I need to be prepared for that moment. And so what the team behind the Simian army was able to achieve is like, normally, once you can be sure for, in production, there will be the time where something is not working. But the time can be, let's say, in 2 days, 3 weeks, in 6 months. That's something you don't know, but you know that you will be hit by an outage. So what they did is like they shortened the time. They enforced the team. Okay, the chaos monkey is running every day in between our working hours. So that's something you have to know. And so they were able to achieve in a proactive way the higher stability of their systems. That's what they have done. But Netflix was not the first company. There are also people, they started earlier at, for example, AWS, as they have created AWS. They have also done some chaos engineering experiments, but on a very deeper level, like with some scripts, some game day scenarios and all this stuff, not on this kind of level as Netflix did it.
Yeah, really interesting. So, I'm curious to dig into more about what you're saying about how it used to be random, but seems like now there's more strategy, or it's more tactical now than before. So I want to dig into that later. But before that, I also wanted to ask about what are the most frequent causes of downtime that typically organizations see that probably someone who's listening to this would probably relate to and say, hey, yeah, that's kind of like us.
Yeah. So of course, the network is not reliable. There is something on the network which is not working. Maybe something is not responding in a specific time, so there is latency, or maybe there are some packages corrupted, or maybe there's a firewall misconfigured, and that's also like the second big cause, misconfiguration. There are some, maybe you have to roll out a big change, maybe you have to reconfigure your load balancing or configuration of your Kubernetes cluster. It's working on your local machine, maybe on dev, but then on staging, QA, maybe in production, it's not working as designed. So that's the two main causes for downtime.
Oh, interesting. And it kind of reminds me of this game Jenga. You played that the game where you pull out a brick from the bottom and you place it on top. It's kind of like that, except that one it's definitely going to fall. But I think with chaos engineering, you're trying to replace those bricks, maybe.
Yeah, but it's a very good example, because today we are building on so many different layers. So we have let's say a Kubernetes, but it's managed by AWS. So it's like running on multiple virtual machines, but you are not the owner of all the machines. And it's like, it's hard for a developer who's maybe just responsible for one single application. He's not able to understand what does it mean to be in production with this application. Is it running in a container, in a pod, in a Kubernetes cluster? What is under my development? What is on the department right next to me who's taking care in production? So it's very hard to get everything in a stable situation.
Yeah, and on one side it's kind of like it's fun to, like, it's a kid's dream to break stuff and build it again, like Legos or something.
Yes.
But on the other side, for an organization, especially the larger ones, it can freak them out, because thinking of destroying production instances, changing up things in the networking, storage, it's scary stuff. It affects the user experience. Especially for those organizations who look for safe, predictable ways of doing things. How do you see them adopting chaos engineering, and any advice that you have for someone who thinks like, I'm scared hearing chaos engineering, how can this be good for me? What would you say to them?
Yeah, I can share some insight from our customers, because that's their challenge. So why they started with chaos engineering is because their production systems are in a way like unstable. They are unpredictable. They are more like in the situation, the teams that are running production systems are more like hunted by their own systems. There are so many incidents coming in because of an outage, and let's say the SRE teams or the SRE group, they should improve the system in a proactive way, but they are not able to, because they are more like under constantly or inside a fire drill situation. Incidents coming in, we need to fix it. Under this kind of pressure, you are fixing the system maybe not in the best way, because you have no time for the best fix, for the best solution. So what they would like to achieve, these large organizations, they would like to do it in a pre-production environment. So they would like to shift left all the efforts to improve the system already in the development cycle. So what they are doing is like, the SRE teams are able to see, okay, there's an incident. Let's pick this incident and recreate a scenario, recreate this incident to use it in an earlier stage, so that my engineering teams or I as a SRE can test my system in the pre-production environment.
All right. Interesting. Yeah. And what's it like for the smaller organizations? Are they different in how they look at chaos engineering? Is it more easy for them to adopt this?
They are, most of the time, they are able to move faster, so they can adopt it in an easier way, because of the smaller group of people, the smaller group of departments that are involved, and so they can move faster. And but the pattern is still the same. They would like to do it in a proactive way, in an earlier stage as production. So we have also smaller customers that are creating specific experiments, or they call it chaos tests. and they are running it continuously to check if the new feature they would like to get in production is still able to handle specific outages. So it's like a regression test. They are doing it. Yes, they are.
Interesting. And who actually ends up being the end user? Is it dev or is it ops or is it both? How do they use chaos engineering differently?
Yeah, so the core persona is dedicated or is coming out of the SRE departments or like people that are also running production. So it's like you build it, run it. It's like the DevOps culture behind, and people that are responsible for production, they are starting with chaos engineering because they would like to get more time to create features, because on features, on the speed, how fast they can deliver features, that's what they are measured on. But if they are now covered or like hunted by incidents, they are not able to provide new features for their customers.
All right. So we have a good background of chaos engineering, what it is, and kind of how it's done. And I want to get into a bit about how it works and the solutions. If you could tell us now a bit about how chaos engineering has evolved and where it is right now. So you said it used to be random, but now it's not random, not as random. Could you tell us about how chaos engineering has evolved and what it is right now, and even a bit about Steadybit and your approach to chaos engineering?
So inside of the principles of chaos engineering, there's also a method described where you are describing a thesis, a hypothesis about how your system should react under specific conditions. And that's something where you create an experiment for. That's something you would like to test. So that's like, this was the next logical step from the early beginnings where people have just started with, let's say, okay, here's my toolbox. I will pick up a tool like the hammer out of the toolbox, and I will use this hammer right now to hit my own system. That's not like what you are doing with chaos engineering. It's more like, in this example, it's more like you are checking if the hammer, the tool, is working properly or not. And that's this evolution we can see in chaos engineering in the time for that's the evolution we can see in chaos engineering from today's perspective. You are starting with your expectations. You are describing what your system needs to achieve, and then you are picking up like a list of potential outages or potential attacks or failure scenarios. You are executing them, and you are still verifying if your expectations are fulfilled by the system or not. That's like the evolution we can see. And it's also that everything is now connected. It's not that you are only running a specific experiment with a specific attack. No, you need a proper monitoring solution. You need to reuse your existing load tests, and everything needs to be orchestrated in a easy and safe way.
Okay. So you're saying that the organization itself would define in what way they want to be more resilient. They want their systems to be more resilient. And then you're saying that the tool like Steadybit would figure out how to achieve that goal by, figuring out what needs to be kind of destroyed at what frequency and what radius and all of that stuff.
Yeah.
Do I understand it right?
Yeah, let me summarize it again in a more technical way, maybe. So
Okay.
you are normally starting today, you are normally starting with like, what is the steady state I would like to see fulfilled all the time? That's like, that's my baseline. That's something my system needs to provide, even under bad conditions. And now you are running a list of potential outages, failure scenarios, and you are still verifying if the steady state is given or not. That's how you're doing it today.
Could you even explain that a bit further? What are some of the details of steady state? Like, could you give us a more realistic example of an example company that has a certain setup? What would be their steady state? Something that's more specific.
Okay. Yeah. Let's assume we are an e-commerce provider and we have an online shop, and there's like a start page where all our products are listed. So now I, as the owner of this shop, I would like to list products even if there was like an AWS zone outage, or maybe my database is gone. So I need to provide something in my software that, let's say, the database is not responding anymore. We need to provide a fallback. A fallback could be, let's say, a cache of all the products. Maybe it could be a static list of the products I'm providing. So now I need to create an experiment and test case where I can just tell, okay, during, let's say, this time period, my online shop needs to respond with a 200 HTTP status code and this list of products. And now I can use this steady state and can inject, let's say, an outage of my database. And now, during the execution, a tool like Steadybit is able to verify if the specific endpoint is still reachable and is responding with a 200 HTTP status code and is listing a specific list of products. That's how you can do it.
Okay. Yeah, that's a great example. Thanks for sharing that. So, considering that, how does it actually work? What happens, in terms, is there an agent that's at work? Is there a Steadybit agent that's installed in AWS? Under the hood, what's happening?
So in our product Steadybit, it's like you have one central platform, and this central platform is connected with different agents you are able to run in your own system. So we have an agent for your virtual machine, an agent for your Kubernetes cluster. So on every node, with the help of a daemon set, one of our agents is running. Or maybe based on customer feedback, we created a special kind of agent. This agent is just connected to your, let's say, AWS account once. And so we can do a zone outage on API level. We can simulate a region outage. We can shut down an RDS instance. It's all something we can do on API level with your cloud provider like AWS. So there are multiple types of agents. And these agents are in a discovery mode. So they are discovering your system all the time. Why? Because your system is also changing all the time. And you need to get a clear picture about your system. For example, there was like an auto-scaling event, or maybe Kubernetes has rescheduled some of your pods to a different node in a specific zone. That's something you need to know to run and experiment on your system. Because with all this discovered data, we are then able, inside of Steadybit, to create an experiment by describing in a very generic way. Let's simulate an outage from all your containers that are running on a specific zone in a specific region by your cloud provider. That's something you can do with Steadybit.
Awesome. And also, how does it work in the sense that it simulates an outage? So when the outage happens, I don't know, how do teams react? Where do they go? What do they do to make sure that things are running? Because when something goes dark, it could be panic. Does Steadybit give out any help or recommendations to say, hey, this thing is down right now, to make sure your system is resilient and can handle this? Go and do that. Are there any recommendations of that sort?
Yeah. So we have a feature which is called, so there are multiple questions I need to answer. So first of all, there is a feature called weak spots, because based on all the data we have discovered, we can analyze all the targets and we can identify so-called weak spots. So maybe there is something already not configured in the best way, or under best practices. So that's where we can do some recommendations for you. You should, let's say, edit how is it called, a readiness probe or a liveness probe inside of your pod. Here's a code snippet we have already created for you. You can do it by your own. Or maybe another weak spot is like, okay, you're running on Kubernetes. This Kubernetes is managed by AWS. Everything looks great. But guess what? Here's one service inside of Kubernetes, which is limited or is distributed to just one zone. So if this zone by AWS is not responding, the service is also not responding. That's something we need to be aware of. And that's something where we can point you to. And that's like the recommendations we can do. And now I lost the first question.
Yeah, I was asking about the Steadybit give out recommendations on what to do or what to fix so that you can stay resilient.
Okay, and the first question was also like that teams don't get into panic mode. So
Yeah.
people are with Steadybit, we are connected, or we have built integrations into your monitoring solutions. So that's one way how you can do it. So for example, if there is an experiment running under control of Steadybit, we can send out like events into your monitoring system so that people are aware of, okay, Steadybit is now executing an experiment. It started right now. Now there is an attack started by Steadybit. And that's all you can see also in your, let's say, New Relic system. So it's like a release marker, but it's more like here's a chaos test running. So people are been informed that there is something going on. And of course, inside of Steadybit, you are able to see if there's an experiment executed. And also there's an API where you can do some webhooks, or you can interact with Steadybit to be notified if there's an experiment under test or not.
Wow, really interesting. So Kubernetes is pretty complex, and there's so many different moving parts. And does Steadybit in any way help to make Kubernetes more resilient, or even re-architect the way that you've designed your Kubernetes clusters? Any thoughts on that, on just Kubernetes and how Steadybit could help with managing Kubernetes itself?
Yeah. So we have something is called recipes. So we have provided a list of potential experiments you can run to verify how good your Kubernetes is working. So for example, are you able to do a rolling update? That's something we can test for you in combination of your load tests, because that's one of my biggest learnings in doing chaos engineering. I was working in a project some years ago, and there are, let's say, there are two requests by the management. The first one was like, okay, here's a load test. That's a specific load your system needs to handle. Please check before you go into production. The team checked everything, works quite good. The second requirement by the management was like, okay, we would like to be able to do rolling updates. Okay, the team checked, are we safe to do rolling updates? Yes, but they never checked in combination the first time before they go into production. Are we able to do a rolling update under load? And they failed quite hard. And that was like a very good example on what you can, how you can improve. And that's also something which is Steadybit is able to do for you.
Wow, really neat. We've heard a lot about what chaos engineering can do for you, Steadybit, and so despite this, the one apprehension that someone who's considering this may have is, I'm too busy for one more project, one more tool. I'm already swamped. There's so many tools to watch. There's so much data. I'm already drowning, in all of this. And you're asking me to get another tool that's going to kind of simulate outages. I'm too busy for this. What would you say to them?
So first of all, we have created Steadybit in a way that you don't need to be an expert to do chaos engineering. It's a very easy way to get started very fast, and you can focus on your use cases. So it feels later on more like a testing approach, where you are just writing another test case, like an integration or end-to-end test, to verify if your system is stable or not. And if you have done it in a proactive way, you are safe in production. So you are not getting so much new incidents for specific resilience or reliability issues, because you have already checked and verified before you are going to production. So if you're doing it, you are getting more time from production.
All right. And where is Steadybit supported or not supported in terms of like cloud, on-premise, anything on those lines?
So there's a support for all Linux OS systems. So if you are running on, let's say, a Linux distribution, EC2 instances, that's all supported. There's a very deep integration into all container runtimes like Docker, Containerd, CRI-O, and so on. That's all supported by Steadybit. We are supporting your cloud providers, Azure, Google Cloud, highly supporting AWS. What else? You can use our product in a SaaS environment. So you can use the platform, our product, in a SaaS approach, or you can use this also on premises. There's no difference. So you can run your own central platform on your cloud infrastructure or on your data center. It's up to you. We have support for the top monitoring solutions like Datadog, New Relic, Instana, Prometheus. They are all deeply integrated in Steadybit. What else? There is support for your existing load tests like by K6, Gatling, JMeter. And there's something very special we changed recently in our product, because we learned from our customers that every system is a tiny snowflake, and we are not the experts to, let's say, write 100 attacks or 100 discovery components based on your internal infrastructure. You are the experts, and that's something our customers requested. Okay, can we do something by our own? So there is a new concept. It's called extensions. So the central platform is provided by Steadybit, and then there are extensions where you can create your own verifications. You can create your own discovery components. Maybe there's a legacy component inside of your system you would like to run an attack on. You can also run your own attack extension. That's something where people can contribute to Steadybit, and it's in an open source way. So all the extensions are open source. There is like an extension for Kong API Gateway, already supported and by Steadybit, and also there's a contribution by one of our customers, Mano, an e-commerce provider from France, where you can simulate an outage on API level, like this route is not responding, or maybe there's latency in specific request on a specific request. That's something you can do. That's what we supported.
Really cool. Wow, that's a lot of integrations, and I think it's really widely, it supports a lot of different tools and solutions that organizations already use.
Yes.
So it looks like a lot of work really got into Steadybit, and I'm not surprised. I mean, 4 years that you've been building this, so it's quite a while. And if someone wants to get started with Steadybit, what's the best way? How do they go about it? How quickly can they get started?
Mm-hmm. So as mentioned in the beginning, I'm a developer by heart, and developers or people from our community, or also people from the SRE department, they first would like to get started with the product. They don't like to talk to salespeople, or they don't like to get a demo or whatever. Let me get my hands into the product. If the product is working good and is fulfilling all the requirements, then I will contact you anyway. So that's why we started with a free plan with Steadybit. So you can play around with the product. You can just sign up on our website, free plan, start free with Steadybit. Then you are able to create a team. You can invite maybe your colleagues if you would like to. And also you are allowed to run up to 10 agents inside of Steadybit to play around with the features. There's no credit card required. There is no limitation in the test period. Please feel free to play around with the product.
Nice. And what are some of the initial results, and some of the good things that your customers see when they adopt Steadybit? What are some of the first results?
So one of the results is like the number of incidents is getting down. So it's incidents related to resilience or reliability issues is getting down. One customer is telling us 30% quarter over quarter, they were able to reduce the number of incidents to reliability issues. And how they are doing it is like, that's the flow they are doing, or that's like the journey they had is, okay, let's start with one experiment. What is the best experiment we should start with? They are taking a look at the incidents from, let's say, last week, or the incidents from last quarter. They are getting all the data out of this incident, and they recreating a specific incident from the past. And then they are starting it once manually. They are seeing, okay, if the system is able to handle this incident now or not. If not, okay, we need to fix it. And then they can reuse the already existing experiment to verify, okay, are we safe now or not? If this experiment is then later on successful, it's been automated. It's been part of their release train. So in front of every big release or big deployment into production, they are executing a list of of experiments automatically via API with Steadybit. And then they are able to see, okay, how big is the risk we are taking? Are we safe to go on production or not? Is there something we can now handle? Or is it maybe even getting worse compared to the last release?
Really cool. 30% quarter on quarter reducing incidents is huge. I think that's like every SRE's dream come true.
Absolutely. This was based on the infrastructure of Kubernetes. So they have recreated a big application into a microservice-driven architecture running on Kubernetes, managed by AWS, and that's how they were able to decrease the number of incidents.
Awesome. And so in the space as well, in with SREs especially, where do you see awareness of chaos engineering? Do you see it as most SREs are aware of chaos engineering, and how much of them are aware, one, and two, how much of them actually practice chaos engineering in some form? What do you see out there?
So the term, or like the principles behind chaos engineering, they are already aware of. It's not a new topic. It started some years ago. It was been pushed by Neflix. There are some other startups and companies out there that are doing chaos engineering. And since the last years, I can see that the number of companies who are already now getting started to do chaos engineering is increasing. So it's like there's more coming in. You can also take a look at the last Gartner report, where they are talking about the digital immune system you have to build, and chaos engineering is one element how to verify how safe you are. So it's like it's now this shift that people are also doing it in their day-to-day life.
All right, neat. And how does pricing work with Steadybit?
Easy. that's the answer. So we are doing it on a team-based approach. You will be charged per team, and there is no limitation on the experiments you are running. There is no limitation on the people that you are inviting to your team. It's just that we are charging you by the number of teams you are using in the product. Why the number of teams? Because it really depends on the size you are running on. So if you are a very large organization, you are not safe if you are running chaos engineering with all people in just one team. Then you are killing yourself or colleagues or applications from your colleagues. That's something you need to handle. And that's where you are creating new teams. That's the pricing model.
Interesting. So it's a very collaborative thing that different teams need to come together.
Yes.
So
that's also something we can see from the customer side. That's like there's one expert group who's getting started to prepare everything for chaos engineering, and then after the creation of first experiments, they are like handing it over to their colleagues. Okay, here's something I prepared for you, or here's something I already executed for you. Here's a report. That's something you need to fix. If you have fixed it, please come back to me, or maybe just replay this test case I already provided to you.
Yeah, that's pretty cool. So is there any training, onboarding help that Steadybit provides, considering this involves multiple teams and it's a culture problem, right? I mean, you're trying to change culture as well, not just tasks and processes, but the whole culture. So is there any onboarding training help that Steadybit provides?
So we created Steadybit in a way that you are very safe to run the first experiment. So there's like a wizard inside of Steadybit that is like asking you specific questions, where you would like to run a specific experiment, what kind of experiment you would like to run. That's how we can guide you. Also, with the help of our weak spots, that's something we can point you to specific areas of your system where you can start. And also, we have a feature called Landscape. It's like a map we are able to build out of all the discovered data of your system to see all the connections in between, how you have separated your, let's say, Kubernetes namespaces or created your Kubernetes namespaces. That's something where we can enable you to do it in a safe way. And then, you use our UI to drag and drop specific scenarios. You can reuse our recipes to start in a very easy way with some guidance along.
Right. All right. Really cool. Thanks so much for all of that information, Ben. It was, quite insightful and exciting, I think, for someone who is interested in chaos engineering. I think you really made the whole idea something that they should try. And that Steadybit seems to even make it very easy with a lot of, stuff that's already designed into the product about, how to simulate outages and even help on how to handle those outages when they happen, and even some of the the results were quite inspiring. 30% improvement in in downtime quarter on quarter. That's huge. So anyone listening to this, if this sounds interesting to you, definitely go and check out what Steadybit is up to. Check out their product, like Ben said. Go and download the trial and play around with it and see what it's capable of. And I think you'll find something that you'll want to use and that can really improve life for you as an SRE or a DevOps person, and eventually for your end users. So definitely go and check out Steadybit. Ben, before you go, got a couple of questions to get to know you a bit. So wanted to ask you first to start off, which I ask every one of my guests on the show. What would be your alternate career if not for your job in tech?
Mm-hmm. Something in the nature, something out, something maybe in the woods or in this kind of because all the free time I can have as a founder and a dad of two kids is something I would like to do outside, or I'm doing right now outside.
Any particular outdoor activity? Do you cycle, trek, or do something else?
Yeah, so it's like mountain biking or hiking or just to be out, just to be outside.
Yeah, neat. Yeah. So you're a CEO, co-founder. So I want to ask about who do you look up to as a CEO from another company? Do you have anyone who inspires you? Who you think I'm a fan of that CEO?
Not a specific person, but all the people, that are on this mission to create something. So it's like all the people who are like doing a startup in tech or non-tech, whatever, but it's more like where you can see all this power, the vision behind, and how people are fighting for their own vision and how to make it successful. That's what I'm a big fan of, and that's what I'm watching and listening.
It's a great response. I think, definitely a lot of enthusiasm and energy there. Yes. When you look around itself.
Yeah, and one thing I would like to add is people who are honest. It's not everything is like happy, or it's not always like to be fun in the startup world. So if people are sharing, let's say, that was my biggest fail, or that was something I did wrong, but I learned X, Y, Z. That's what I'm looking for.
Really cool. Yeah, that is rare though. And it is refreshing when you see it. Honesty. The next question. So, as CEO, you obviously wear many hats. You're doing different roles at different times. But which of it do you most resonate with? Which are you most proud of, or which do you enjoy the most? Is it being the business guy, being the finance guy, the product guy, or the developer, or the marketer? Which of these really excites you most?
My biggest motivation, even before Steadybit, is like I, as a developer, product engineer, was able to achieve something, and then I would like to talk about it, to share it with other people. And this immediately getting this kind of feedback, that's my biggest motivation. So it's like the head of product engineer guy.
Really cool.
Where I can talk with our customers, where I can talk with some people on a conference, or maybe on Stack Overflow, to understand what kind of problem they have and what they would like, and how can I be helpful to fix this problem.
Well, that's great. Yeah, you want to stay close to the product.
Yes.
What would you say is the best thing to happen in tech over the past decade?
Wow. In my bubble, it is this the shift from all the big monoliths into microservice-driven architecture. That's
Okay.
where the speed is coming up. That's where you can be so creative, where you can get new features, you can reuse existing very, very unique technologies to find the best solution for your product. It's like this big, I'll call it big toolbox of technology you can use today to solve a specific problem.
Mhm. Okay, cool. The last question for you, Ben, is where do you go to find out what's the latest and greatest in the tech space? What's your source for news and, what's trending?
Yeah, so it's no longer Twitter, sorry. Normally the answer, some time ago, it was like watching the Twitter stream, but nowadays it's more interesting for me to see what's going on LinkedIn, and then what everyone is like writing about on blog posts. So something I can consume in an async way, like listening to a podcast, something in this area. Yeah. And yeah, it's Medium, LinkedIn, it is Reddit, it is still Stack Overflow for me, sometimes not so often.
Neat. Yeah, I think LinkedIn has definitely come a long way since back in the day. It's kind of like really addictive now. You find it hard to leave LinkedIn sometimes.
It is, absolutely. And it's also like the quality is very high. It's still very high. It's not like so noisy like Twitter.
Yeah. All right, Ben. With that, we come to the end of our chat for today. I really enjoyed hosting you. Thanks for joining us. Thanks for sharing all of that with us today. And,
my pleasure.
And for everyone who's watching, another reminder, go and check out Steadybit and what they're doing with their products. Really cool, what we just heard. And if you want to keep track of what we're doing here at Amazic, just visit us, amazic.com. Check out all of our other interviews, articles, job listings, KubeCon coverage, etc. Follow us on our YouTube channel. And you'll be in the know. With that, I'd like to sign off. And thank you so much again for joining. Thank you.
Thanks a lot for having me.